Section 5.5 is about roots of real numbers. The key concept is the understanding that square roots and squaring of numbers are inverse operations. So if you take the square root of 9, that's the inverse of taking 3 squared. 3 squared is 9, and the square root of 9 is 3. So those operations are inverses of each other. But now we're going to add to the mix the nth power and the nth root. There's more than just a square root, there's a cubed root and a fourth root and so on. You can use other numbers other than just a square root. So here's the definition of having something going to the nth power or the nth root in this case. And it's best if you just look at the example. 2 to the 5th power is 32 because 2 times itself 5 times is 32. So we could say 2 to the 5th power equals 32. And we could also say the 5th root of 32 equals 2. And this is how we write an nth root. Instead of saying the square root, we say the 5 or the 5th root of 32. A couple of words. The number that's on the outside is called the index. So in this example, my index is a 5. The radical sign is what it always is. And the number underneath is called the radicand. So in this case, the 32 is the radicand. Now the principal square root is the non-negative root when there are more than one. Example would be square root of 16. Now there's actually two numbers that if you square give you 16, but typically when we just say square root of 16 we're only looking for the positive version, and that's called the principal root. Here's a concept summary for what to do with nth roots when we're dealing with positives and negatives. Well, when you have the nth root, when you have the n that's an even number, then you have to look at what kind of a radicand you have. If the radicand is positive, then you're going to have a solution that's plus or minus, because in this example, plus or minus 5, if taken to the 4th power, will be 625. But if your radicand is negative, then you're going to have no roots, because you can't take the square root of a negative number, and it also turns out that you can't take an even root of a negative number. Now if the index is odd, again, you look and see if the radicand is positive. If it's positive, then you're only going to have one positive answer, because 2 to the 3rd power gives me 8. Negative 2 to the 3rd power gives me negative 8. So that wouldn't be included in this example here. If the index is odd and the radicand is positive, you're going to get a positive solution. Also, if the index is odd and the radicand is odd, you're going to have one negative solution. So down here, if you just pause the video and read through this, you'll see a couple of examples for how to use positives and negatives with square roots. Here's some examples using square roots and nth roots. Over here, the square root of 25 is going to give me a 5, and the square root of x to the 4th, the way you can write that is the square root of x squared squared. And remember that the square and the square roots will cancel, leaving a 5x squared, and then don't forget the plus and minus is on the outside, so it has to stay there. That's how that one simplifies. Over here we have a negative on the outside, so we're not going to worry about it right now. Y squared plus 2 to the 8th power really means to the 4th power squared. Now why do I care about squaring it? Because when you square a square root, the square root and the squares will cancel, leaving me y squared plus 2 to the 4th power, but then don't forget that that's going to be negative. Down here we have a 5th root, so we're asking ourselves the 5th root of 32, the 5th root of x to the 15th, and the 5th root of y to the 20th. That's really what's going on. Well, what number to the 5th power is 32? The answer is a 2. Here, if we can get some exponent with a 5, then we can cancel the 5th root. Well, how can I get a 5 when I have a 15? I take a cube. So x to the 3rd to the 5th, you would multiply those. So if I rewrite this as the 5th root of x cubed to the 5th, I can cancel the 5th root and the 5th power. And then likewise over here, if I do the 5th root of y, 4 times 5 is 20, then I can cancel the 5th root. So I have 2x cubed y to the 4th. And the last one, the square root of a negative number. Remember, if you have an even radical sign or an even root, in this case it's a square, so it's a 2 there, you cannot take a negative, so we would say that this is no solution. You can't take the square root of a negative number. There's some other things to look at when dealing with radicals. When you're taking something to the nth root of an even power, so if the power is even and the result is odd, then you must use an absolute value. Here's an example. I'm taking the square root of a square, which is an even exponent. Now when I cancel those and I get -5, my exponent is now a 1. That's really a -5 to the first power. Then you have to take the absolute value of that. Likewise, when I take the square root of an even power, which is a 6, and it becomes a 3, because simplifying this would be -2 to the third squared. And then when I take the square root, the square and the square root will cancel. But it started out being an even, and it ended up being odd. Then you take the absolute value, so you'd end up with an absolute value, which is 8. So that idea, we're going to do some examples with that. Here I have an 8th root, and the root and the exponent will cancel, leaving me just an x. Now what exponent's on this? It's a 1. So it started out being even, or an 8, and ended up being odd, so I have to put an absolute value around the x. So the answer here would be the absolute value of x. Over here, 4th root, that's an even. So I'm looking for the 4th root of 81. And then I'm looking for the 4th root of a plus 1 to the 12th. Now instead of doing to the 12th, I'm going to do it to the 3rd, and then take that to the 4th, because 3 times 4 is 12. Now the 4th root of 81 is just 3, because 3 to the 4th is 81. Over here, the 4th root and the 4th power will cancel, leaving me a plus 1 to the 3rd. But it started out being a 12, which is even, and ended up being a 3, which is odd. So I need to put absolute value bars around that piece for the final solution. The last thing I want to talk about when dealing with radicals is that not every square root is going to be a whole number, and they're not always going to be rational. Sometimes they're going to be irrational numbers where they don't repeat or they don't terminate. You also need to know how to type these into your calculator, so it's a good chance for you to do that right now. If you take the square root of 2, you get an irrational number, and the way we write that is we use a squiggly equal sign because it's not really equal to this. So I'm going to go to 3 decimal places and say that square root of 2 is about 1.414. Cube root of 19, it would be useful for you to know how to do the cube root on your calculator. Every calculator is different. When I do it on mine, I get a 2.668, and it's going to be negative because the negative sign's outside the radical. And then the 4th root of 48, again, is an approximate number, 2.632. It would be good for you to type that in and figure out how to do that on your calculator.